In this video, I'm going to show you how to work with Longhorn as a Kubernetes storage solution. So let's dive deeper into Longhorn. Hello everyone, my name is Mohammed and welcome to Cutoffs by Mo, my YouTube channel. If you're working with Kubernetes, you definitely know that you need a storage solution to use in your cluster, okay? And you have different choices. But Longhorn can be one of your choices as well. Personally, I'm very interested in this amazing tool because of many reasons, such as it's very easy to set it up in a cluster, it's very easy to use, and also it provides many features for your volume, such as snapshots, the restores, backups, and also you're able to replicate your volumes across different nodes to ensure high availability and redundancy. Okay, it's very important. But before installing Longhorn in our Kubernetes cluster, I'm going to show you the architecture of Longhorn based on this picture. Okay? This is just an example to understand the architecture of Longhorn. The first thing that you need to know is that Longhorn has a very important component called Longhorn Manager. Longhorn Manager is actually responsible to communicate with Kubernetes API server to create and manage your volumes. Okay? And whenever you make a request to create a volume, Longhorn Manager creates that volume for you, and also it creates an engine or a controller for that volume. As you can see here, each volume has a dedicated engine or a dedicated controller. Okay? And you need to know that Longhorn Manager creates that engine on the node that the volume is attached to. Okay? Another amazing feature of Longhorn is replication. You're able to replicate your volumes across different nodes. In this picture, volume 1 has two different replicas. The first one is inside node 1 and another one is inside node 2 to ensure high availability and redundancy. Okay, let's imagine that, for example, node 1 goes down, okay, and the part of your application goes to another worker node to continue its life. And before that, Longhorn created multiple replicas for your volume across different nodes. And it means that that disaster has no impact on the data of your application because you have multiple replicas of your volume across different nodes. Okay, it's very important. And another thing that is so important is that Longhorn actually is not a separate cluster from Kubernetes cluster. It means that you install Longhorn inside your Kubernetes cluster. And actually, Longhorn uses the storage capacity of your worker nodes as its storage pool. Okay, let's imagine that you have three different worker nodes, and each of your nodes has its own storage capacity. And overall, Longhorn uses the storage capacity of your three worker nodes, for example, as its storage pool. And whenever you increase the number of your worker nodes or whenever you expand the storage capacity of your existing worker nodes, it means that you're expanding the storage pool of Longhorn because Longhorn has not a separate storage pool. It uses the storage capacity of your worker nodes. It's very important. Okay? So let's go to install Longhorn in our Kubernetes cluster to show how it works. I go to the documentation of Longhorn. First of all, I click on quick installation here. Actually, before installing Longhorn in our Kubernetes cluster, we need to install some packages, some Linux packages on our worker nodes to meet the requirements of Longhorn. Okay, so I scroll down here. There is a command here. Actually, there is a script called environment underline check.sh, and we need to run this script in our Kubernetes cluster. It actually checks the worker nodes to ensure that these worker nodes meet the requirements of Longhorn or not. So I copy this command and I go to the Kubernetes cluster. Actually, I have a cluster includes one master node and three worker nodes. Okay, so I paste this command to run this bash script. So I need to actually install JQ, apt install JQ. Very good. So I run this command once again to check the actually worker nodes to ensure that they meet the requirements of Longhorn. So I run this command. I have 3 different worker nodes, and all these worker nodes need to meet the requirements of Longhorn. Okay? It checks kernel release, check ISKZ, and NFS clients, NFS packages, and everything is good. It means that we have no errors because I already installed prerequisite packages on my worker nodes. Okay, but if you run this command and then you see some errors, it means that you need to install some packages on your worker nodes. The first package you need to install is OpenISKZ. Okay, you need to run this command inside your worker nodes, not master node, just your worker nodes. Okay, so I copy this command and I go to the first worker node here and I type sudo apt-get install OpenISKZ, and yeah, it's already the newest version and this is available in my Linux environment. I go to the second worker node and yeah, everything is good. I go back to the documentation, and another command is modprop iskz underline TCP to ensure iskz underline TCP module has been loaded. Okay, so we need to run this command on our worker nodes. Sudo modprop here, another worker node, and the last worker node here. Okay. And the last Linux package you need to install is NFS client, NFS v4 client. Okay, so I copy this command apt-get NFS apt-get install NFS common, and I need to run this command to install this NFS client on our worker nodes. So I type sudo apt-get install NFS common. It's already the newest versions. This is available, and another worker node, and very good. If these packages are not available for you, you need to install these packages. These are actually the prerequisites of Longhorn, okay? And after installing these packages, you can go to install with Helm or kubectl or something like this. I prefer to install Longhorn with Helm. So the first command you need to run is helm repo add to add the repository of Longhorn. I go back to the master node and I type helm repo add. The helm repo actually already exists with the same configuration. That's very good. And then I type helm repo update. And the last command here is this helm install Longhorn. The namespace is longhorn-system. This is the default namespace of Longhorn. And if this namespace does not exist, it creates the namespace for you. And the version of Longhorn we're gonna install is this 1.8.0. So I copy this command and I run this command in my master node here. Very good. Longhorn has been installed inside my Kubernetes cluster. If I type kubectl get pod-n longhorn-system, I need to wait for all pods Longhorn to be up and running. So I pause the video and I'll get back here if all pods are up and running. Okay, as you can see here, right now, all pods related to Longhorn are up and running. Very good. Um, so now instead of getting pod, I type kubectl get daemon set, and these are all daemon sets related to Longhorn. One of them is Longhorn-manager, okay? This is a very important component, and as we said earlier, it actually responsible to create and manage your volumes, okay? And this is a daemon set, and it runs on each of your worker nodes, okay? Another command is kubectl get SVC, and these are the services related to Longhorn, and one of them is Longhorn-frontend. If you want to access to the UI of Longhorn, you need to expose the Longhorn-frontend service. And you have different options such as using an ingress object or node port or using kubectl port forward. It depends on you. We are now in a test environment, so I use kubectl port forward. But for you, I recommend you to use ingress object. Okay? So now I type kubectl port forward svc slash longhorn-frontend. The namespace is longhorn-system dash address. All IPs, the port 8080, and the port inside the service is 80. So I type 80 here. Very good. I already added the private IP of my node to the etc host of my local machine. Okay? Because of that, when I go back to the browser, instead of typing the private IP of my Linux, actually Kubernetes node, I use the DNS name that I added to the etc host of my Linux machine. So I type longhorn.local, and the port that we exposed is 8080, if you remember here. So yeah, this is the interface of Longhorn. So we successfully installed Longhorn in our Kubernetes cluster. But unfortunately, Longhorn doesn't have an authentication system. It doesn't have a login page, okay? Therefore, I highly recommend you to use Ingress to expose Longhorn-frontend service, because Ingress controllers provide you a basic authentication. It means that using Ingress controllers, you can set up a basic authentication for your Kubernetes services, such as Longhorn-frontend service. Okay? So, very good. So now it's time to create our first Longhorn volume. Okay? Therefore, I decided to deploy an application that needs a database, and that database needs a persistent volume claim. In this situation, Longhorn comes into the play to create and manage that volume to store the data of our application. The name of the application I want to deploy is Wiki.js. Wiki.js is used for creating and managing documents. Okay, you can use it for your personal documents, or you can use it for your company as well. Okay. But the most important thing that this application needs to connect to a database, and the database needs a volume actually. Okay, it needs a persistent volume claim to store its data. Okay, so I go to Wiki.js. First of all, we need to create the resources. We need to deploy and install the resources of our database, and then I will deploy the application itself, because that application needs to connect to a database. The first resource actually is db-config map. The config map has 4 important key value pairs: the name of the database, the username, the password, the PG data. And first of all, I type kubectl create NSB key, and then I apply this config map. So if I type kubectl get config map -nv key, you can see that this config map has been deployed in Wiki namespace. Another important resource is db-pvc, persistent volume claim. If you're working with Kubernetes, you definitely know that what is persistent volume and volume claim. A persistent volume, or a PV, is a piece of storage in the cluster that has been provisioned by an administrator or dynamically provisioned using storage classes. Okay, And a persistent volume claim or a PVC is a request for storage by a user. Okay, it's similar to a pod because pods consume node resources and PVCs consume PV resources. Okay, so the kind here is persistent volume claim. You can also define the storage class you want to use in your manifest, but I didn't specify it because I'm happy with the default storage class of my Kubernetes cluster. If I type kubectl get storage class, you can see that the default storage class of my Kubernetes cluster is Longhorn. So I don't need to specify the storage class here. But if you have multiple storage classes in your Kubernetes cluster, you can define the name of the storage class you want to use. Okay. And also the access mode is read write once. I'm happy with it, but you can change it to read write many if you want. For example, in some situations, you create a volume and you have different pods and different nodes, and all of them want to access to that volume that you created. Okay, you can change it to read write many in those situations if you want. But now I'm happy with read write once. And the request storage size is 10 gigabytes here. So I type kubectl apply -f db pvc. Okay, so now Longhorn first of all provisions and creates a volume or a persistent volume for us, and then it binds our persistent volume claim to that persistent volume. So if I type kubectl get pvc-n wiki, we can see that the status of our persistent volume claim is bound. So if we get back to the Longhorn interface and we go to the volume tab here, I refresh this page. And yet we can see that our volume, actually Longhorn binds our volume to the persistent volume claim or PVC that we created earlier. Okay. The PVC is now bound, but the state of our volume is detached. So now it's time to attach our volume to a workload. Okay. So we have a file here called db-deployments. Our database deployment, the name of the container is Postgres. It uses two important resources. The first one is the config map that we created. And another one is the persistent volume claim that we created earlier because this database needs to store its data. And another resource here is service. The service related to this workload here, actually. So I save the file and I type kubectl apply -f db deployment. Very good. So if I type kubectl get pod-n wiki, the status is container creating. So we need to wait for it to be up and running, and then I will get back here. Okay, so now the pod is up and running. Very good. So now let's go back to the Longhorn interface. I refresh this page. And yet we can see that the volume is attached to the workload that we created. Very good. If we get back to the architecture of Longhorn here, actually, so now we have a pod and also a volume, and the volume is attached to the pod that we created. Okay. And also, Longhorn Manager created an engine or a controller for that volume. And also, our volume has multiple replicas. To prove it, I get back to the Longhorn interface. I click on the volume here. We can see that the number of replicas of the volume is 3. The first replica is inside worker 2, another one is inside worker 3, and the last one is inside worker 1. So we have 3 different replicas on 3 different nodes to ensure high availability and redundancy. You can increase this number or decrease. So to do that, I click on this button. I click on update replicas count. For example, I change it to 2 replicas. For example, here. And then I want to delete one of these replicas. For example, I want to delete the replicas related to Kubernetes Worker 2. So I click on delete. And now this volume has two replicas. The first one is inside worker 3 and another one is inside worker 1. If you want to increase the number of replicas, you can click on update replicas count again and change it to 3 replicas, for example. And after that, Longhorn will rebuild that replica for you. So if I click on OK, it actually adds a volume, actually a replica here for us. And then Longhorn will rebuild that replica. Because of that, right now, the state of our volume is now degraded. And after rebuilding that replica, the state of our volume will be changed to healthy. So we need to wait. And yeah, if we get back to the volume now, you can see that the state of our volume is now healthy because the state of all replicas are running and all of them are healthy actually. So very good. Um, Another important thing that you need to know that each volume in Longhorn has many different features. You can enable them, disable them, you can customize them if you want. And I want to explain all these features related to Longhorn volumes. We talked about update replica count. Another feature here is update data locality. But what is data locality? Data locality feature ensures that a replica of a volume is located on the same node as the pod using it. Okay, this can improve performance. And there are 3 different settings: disable, best effort, and strict local. If you set it to disable, it means that no guarantee of a local replica on the same node as the workload. And if you set it to best effort, it means the Longhorn attempts to keep a replica on the same node as the workload. But if it's not possible due to constraints like insufficient disk space, the volume remains operational without a local replica. And another option here is strict dash local, and it means the Longhorn ensures that the only replica is on the same node as the workload, providing higher performance. However, if the node fails, the volume becomes inaccessible, unfortunately. If you want to set the data locality to strict dash local, first of all, your volume must be on detached mode and the number of replicas should be 1. And after that, you can set it to strict dash local if you want. Another option here is snapshot data integrity. It's very important. Longhorn is capable of hashing snapshot disk files and periodically checking their integrity. Okay, when a snapshot disk file in one replica is corrupted, Longhorn will automatically start the rebuilding process to fix it. Okay, um, for setting up this option here, you can follow the global setting or you can ignore the global setting. It depends on you. If you want to follow the global setting, you can set the option here like this: ignored, follow the global setting, and then I'll go to general settings of Longhorn and I search for integrity. Okay, so there is an option here called snapshot data integrity and its value is fast check. You can set it to disable or enable or fast check here. Okay, and another important option here is snapshot data integrity check cron job. The most important thing that the checksum calculation negatively impacts the storage performance. Okay, to lower down the impact, the recommendation is checksumming and checking snapshot disk files can be scheduled to off-peak hours. Okay, by snapshot data integrity check cron job here. Okay, very good. Um, Another option here is update backup target. I will skip this option right now because we have a specific section in this video for backups and restores, and I want to show you how to take a backup from a volume, how to restore it, how to define a backup target. Because of that, I will skip this option right now, but I will talk about it in a few minutes. If in a few minutes, so don't worry about it. The next option here is update Replicas Auto Balance. But what is Replicas Auto Balance? Um, the Replica Auto Balance feature in Longhorn helps you to automatically distribute replicas across nodes for better redundancy. Okay. Um, For this volume, you can follow the global setting or you can ignore the global setting using these options here. If you check it to ignore and follow the global setting, it means that you want to follow the global setting, or if you set it to disabled, it means that actually um, replica auto balance is turned off. And Longhorn will not move or rebalance any replicas, even if a node becomes available. For example, a new node is added to the cluster, okay? And Longhorn doesn't redistribute existing replicas to the new node. If you set it to least effort, it means that Longhorn tries to balance replicas to ensure minimal redundancy. For example, let's imagine that we have a volume called volume V1, and volume V1 has 3 replicas on the same node. Longhorn detects an available node and move one replica to the node to improve redundancy. And another option here is best effort, and Longhorn actually attempts to balance replicas evenly across nodes and zones. Okay, you can configure replica to balance for its specific volume using these options, or you can follow the global settings, and it applies on all volumes actually. So I search for auto balance. Yeah, replica auto balance here. Disable least effort and best effort. You can specify the value you want here, and your volume can follow the global setting, or your volume can ignore the global setting. It depends on you. Another option here is allow snapshot removal during trim, but before that, I'm going to talk about trim file system. It's very important. Since version 1.4, Longhorn supports trimming file system inside Longhorn volumes. Okay, trimming actually will reclaim space wasted by the removed files of the file system. Longhorn doesn't trim the file system automatically. Okay, you need to do that manually using this option, trim file system. Okay. And another option here is allow snapshots removal during trim. The setting allows Longhorn file system trim feature to automatically mark the latest snapshot and its ancestors as removed and stops at the snapshot containing multiple children. Okay, it depends on you. You can follow the global setting, or you can specify it for this specific volume if you want. And another option here is soft anti-affinity. Soft anti-affinity. I go to the setting here and I search for soft anti-affinity here. Yep, here. We have 3 different types of soft anti-affinity settings: disk level, node level, and zone level. First of all, let's start with node level. Sorry, node level. Node level means that the setting determines whether multiple replicas of the same volume can be scheduled on the same node. Okay, if you check it like this, it means the Longhorn allows scheduling a replica on a node even if it already has another replica of the same volume. For example, if node A already has the replica for volume X, Longhorn might still place another replica for volume X on node A if needed. But if you uncheck it like this, Longhorn doesn't allow scheduling a replica on a node that already has a replica of the same volume. For example, if node A has a replica of volume X, Longhorn will ensure no other replica of volume X is placed on node A. Okay, it's very important. Another option here is zone level soft anti-affinity. It actually controls whether multiple replicas of the same volume can be scheduled in the same zone. If you check it, it means a Longhorn allows scheduling replicas in the same zone if necessary. For example, we have a zone called Zone 1, and Zone 1 has node A and B. Okay, node A, already has a replica of volume X. Longhorn might place another replica of volume X on node B if required. But if you uncheck it like this, it means the Longhorn doesn't allow scheduling replicas in the same zone. For example, if Zone 1 already has a replica of volume X, Longhorn will only place new replicas in other zones like Zone 2. Okay? Another soft anti-affinity here is disk level. This setting controls whether multiple replicas of the same volume can be scheduled on the same disk within a node. Okay? If you check it, it means a Longhorn allows scheduling replicas on the same disk, but it prefers using a different disk if one is available. Okay? For example, node A has disk 1 and disk 2. If disk 1 already has a replica for volume X, Longhorn will try disk 2 first, but can still place another replica on disk 1 if no other option exists. Okay? But if you uncheck it, it means that if disk 1 has a replica for volume X, Longhorn will not place another replica for volume X on disk 1, even if it has space. It's very important. So these are the Longhorn features, the Longhorn volume features. You can enable them, you can disable them, you can customize them if you want. And okay, so now it's time to work with backups and restores in Longhorn. After this section, you will find out how to create a backup, how to restore it, and how to work with it. Before, I decided to show you practical, so I deployed a demo application in my Kubernetes cluster, and I want to create backups from the volume of that application. I want to restore the volume of that application and so on to show you how it works. Okay, so if I go back to my terminal here, I type ctl get pod -n wiki. There are two different pods in this namespace. The first one is related to my application, Wiki.js. Wiki.js is used for creating and managing documents, okay? You and your teammates are able to create your documents using Wiki.js application. But the most important thing that this application connects to a database, and the database needs a persistent volume. If you remember from the previous sections, we deployed a persistent volume here, okay? This persistent volume. And our database, this database is using this persistent volume as for storing its data. Okay, it's very important. So first of all, I go to the interface of my application. So I type wiki.local. So first of all, I need to log in to my application. Longhorn @demo.com and a password. Okay, this is the interface of our application, Wiki.js. Okay, and right now I have a document here called Longhorn demo. I can edit this document. I can see the history of this document and can convert it. I can duplicate it, rename it, and delete this document here. For example, if I click on edit, I'm able to edit this document here. Okay. So now at this point, I want to create a backup from the volume of this application. Therefore, I get back to the Longhorn interface. I select the volume I want to create a backup from it. And if I scroll down here, and there is an option here called create backup, but it's now disabled because backup target default is unavailable. The first step to create a backup using Longhorn is that you need to integrate your backup target with Longhorn. This backup target actually can be, for example, Amazon S3, Minayo, or any other cloud storage solutions. It depends on you, okay? But for this demo, I'm gonna use Minayo as a backup target, and I need to integrate Minayo with Longhorn. So I have a Minayo instance, and its address is minayo.local. And I need to log into my Minayo instance here. Very good. There is no buckets in my Minayo instance yet, but Longhorn actually needs to connect to my Minayo instance, needs to connect to my Minayo bucket. Therefore, I need an access key and a secret key. Therefore, I click on access key, create secret key, and I enter name, for example, Longhorn, and I click on create. It gives me an access key and a secret key. So I copy access key first. But before that, I have a very important file here that I already created called minayo-creds.yaml. If I open it, this is actually a secret. Its kind is secret, and it has three important key value pairs: access key ID, access key, and endpoint. Okay. I'm going to integrate Minayo with Longhorn, and Longhorn actually is able to connect to Minayo using this very important secret. Okay. So first of all, I need to enter the access key. I need to actually encode my access key. So I copy the access key here. I type echo -n, the access key, pipe it to base 64, and I copy access key, and I go back to this file, and I place it here. Okay. And the secret key, I copy it. I type echo -n, the secret access key base 64, because we need to encode the data. So I copy the encoded data from here, and I place it here as well. Very good. And another key value pair is AWS endpoint. So if I copy this encoded data, and if I decode it, base 64-D, it returns the IP address of my Minayo instance and its port. Okay, you are able to use DNS name instead of actually an IP address. It depends on you. There is no limitation. But in this case, I'm using actually a private IP address. But you are able to use a DNS name instead of a private IP address or a public IP address or whatever. Okay. So the AWS endpoint is true right now. I don't need to change it. I don't need to replace it. But I replaced access key ID and secret access key with new values from here. Okay. And then I need to actually deploy this file and this secret inside Longhorn-system namespace. So I type kubectl apply-f minayo-creds-n longhorn-system. Sorry, Longhorn system. So if I type ctl get secret-n Longhorn system, we can see that our secret has been added in this namespace. And Longhorn actually uses this secret to connect to our Minayo instance and our Minayo bucket actually. So the next thing I need to create is create a bucket. So I click on create a bucket. Its name is Longhorn, for example. I click on create bucket here. Very good. So the next step is going to setting and click on backup target. Longhorn has a default backup target, but this default backup target doesn't have any URL here. You can edit this default backup target, or you're able to create new backup targets if you want. It means that it's possible to have multiple backup targets in Longhorn. Okay, so in this case, instead of using and editing the default backup target, I prefer to create a new one. So I click on create backup target. Its name, for example, is Longhorn-demo, and its URL is s3 colon slash slash. The name of the bucket that we created is Longhorn. If you remember, the name of the bucket here is Longhorn. You need to enter the name of the bucket first, assign the region. If I click on configuration here, the region I'm using is US East 1. So I enter the region here and slash. Okay. And we need to actually enter the credential secret that we created. The name of the credential secret here is Minayo-Chris. Please pay attention that you need to deploy this secret inside Longhorn, the system namespace. So I enter it. And the poll interval, you can specify the poll interval here. Set 0 to disable the polling, okay? So it depends on you. I click on OK. And yet, as you can see, the status is available. It means that Longhorn successfully connected to our Minayo instance, to the Minayo bucket. Okay, so if we get back to our volume, the create backup here is now disabled because this volume is using the default backup target. So I need to change the default backup target for this volume from default to Longhorn-demo. So I get back to this volume, and as you can see that the create backup target button is now enabled. So now I'm able to create a backup from the volume of my application. So I click on create backup. I'm able to add labels to this backup. For example, I type the label key is app and the value is wiki.js, the name of the application I'm using. And I click on full backup. I click on OK, and I need to wait. As you can see, this is the backup of my volume. And if I go back, and if I go to backup tab here, if I click on it, yeah, there is a new entry in this tab. This is the backup, and the last backup at a few seconds ago. Okay, very good. So if we get back to Minayo instance, there are new objects in our newly created bucket. Very good. Overall, there are two different ways to create backups in Longhorn. The first way is creating backups manually, as we did earlier using this button. And another way is creating backups automatically based on a cron job. For example, you can say that, hey, I want to create backups every night, every day, every hour, or whatever, okay? In this situation, you just need to click on add. And if you want to create a recurring job for your backups, you just need to change the task from a snapshot to backup. And then you need to define a retain. If the retain is 1, it means that it just keep the last backup for you. If you change it to a value something like 3, it means that it keeps 3 last backups for you. So it depends on you. I just want to keep the last backup. And another option here, another actually setting is cron. You need to generate a cron, or you need to specify a cron here. For example, I change it to something like this. And it means it means that Longhorn creates backup at 5 a.m. every day for me. Okay, I click on OK. You can specify groups and labels here. The label is app equals to Wiki.js. You can add labels here if you want. I click on OK. And I created a recurring job here. If I go to recurring job tab here, a new entry has been added. This is the recurring job that we created here. Okay, very good. And it means that Longhorn creates backups for this volume at 5 a.m. every day. Its label, its retain, its concurrency, and so on. Okay, very good. So now it's time to restore our volume. But before that, we need to destroy our document in Wiki.js application. First of all, I will delete this document, and after that, I will restore the volume of my application, and then this document will be added here once again. So first of all, let's delete this document. And now there is no document in my application. So let's go to restore the volume. To restore it, I go to Backup tab here. I select the volume I want to restore it. And this volume has just one backup, okay? And I click on Operation and Restore here. Longhorn actually creates a new volume for us. Therefore, you need to specify a new name for this newly created volume, okay? Because Longhorn wants to create a new volume. So you can actually specify a new name or using a previous name. I prefer to use a new name, so I type wiki persistent volume, wiki-pv, okay? The number of replicas is 3. Data engine is v1. Access mode is read-write once. It's OK. Okay, so I click on OK. If we get back to volume tab, as you can see here, a new volume has been added here, and its name is wiki-pv. Its size is 10 gigabytes. Its access mode is read-write once. Okay, so we need to wait for this volume to be in detached mode. Okay, so I pause the video and I'll get back when the state of this volume is in detached mode. Okay, so now the state of this volume is detached. The next step is selecting this volume and click on this. And I click on create PV/PVC. We need to bind this volume to a persistent volume claim. We need to create a PVC. Okay. If we get back to terminal, I type get pvc-nwiki. There's already a PVC called wiki-pvc. So I type the namespace is, for example, wiki, and the name of the PV will be actually the name of the PV. The name of the PVC will be the name of the PV. Okay. And the storage class name is Longhorn. Very good. So I click on OK. And the status is bound. It means that our persistent volume claim actually is bound to this persistent volume. So if we get back to terminal and if I type get pvc-nwiki once again, you can see that there are two different persistent volume claims here. And the name of the new persistent volume claim is wiki-pv. This is the name of the persistent volume that Longhorn created. Okay, so now let's go to our wiki.js directory here. If we get back to Longhorn, you can see that the previous volume actually has been attached to this workload, the workload related to database. So I need to go to db-deployment, and I need to change the claim name from wiki-pvc to wiki-pv. I save it and I type kubectl apply-f db deployment get pod-n wiki, and it's now container creating. Okay, and the new workload is using the new persistent volume claim. Okay, so I'm waiting for this new pod to be up and running. Okay, so now as you can see that our new pod is now up and running, and if I type kubectl describe a pod, the new pod here -n wiki, you can see that there is a new log here, attach volume that attach succeeded for volume wiki-pv, the new persistent volume that Longhorn created. Okay, so very good. And if we get back to our application and if I refresh this page, yeah, you can see that our document has been added here once again because we stored the volume of our application successfully. Very good. As you can see, the previous volume is now unused, so I can delete the previous volume. So I click on delete. And the previous volume is now deleting. Very good. We successfully understood how to actually create a backup target, how to create a backup manually, how to create a recurring job, a cron job for our backups, and how to restore our backups. Very good. Thank you very much. I hope you like it and see you soon.